Dear conference participants, this report is dedicated to describe how it is possible to organize educational process for technical education students, so the students can proceed fully functional remote laboratory work, using only real laboratory equipment and without using any virtual emulators. Really, the traditional educational system assumes that a lot of people must meet together in one room, but unfortunately, there are reasons that does not allow to proceed a traditional educational process. First reason is the spread of infection disease COVID-19. This problem remains relevant for worldwide in any country. In addition to the disease of COVID-19, other important reasons also relevant for many regions in the world. Particularly Ukraine is now facing open aggression of despotic totalitarian empires. As a result, educational institutions are forced to implement various electronic educational mechanisms. A new original approach to controlling an arbitrary laboratory device is presented. Such device can include a limited number of buttons for manual information input and an indicator for visual output of information. The main goal of this work is to ensure effective operation and interaction between teacher and remotely connected students, and also complete control over the quality and completeness of the laboratory assignments. The learning management system can be easily replicated because it consists only popular and globally common components. For example, 7 copies of such a learning management system has been already created. System has been successfully operated for 2 years. As an example presented in the article, an object of research for students is the programming of ATmega 8 microcontrollers using a development board with this controller. The development board contains a matrix with a ATmega 8 controller, a digital screen with 4 segment indicators, 4 buttons that can be pressed simultaneously or in any sequence. The board is connected by a 10-pin cable to a USB ASB programmer, and this programmer is connected to free USB port of workstation or laptops. Previously, students worked with such development boards directly, but now, unfortunately, students cannot connect development boards to their laptops and work directly with it. Therefore, to fully replace such traditional work with the development boards, a laboratory learning management system was created, consisting of the following hardware components. Development boards with ATmega 8 microcontroller, USB ASP programmer, microcontroller Chipkit Uno 32, to which a 4-pole relay is connected. Microcontroller plays a role of the student's remote hand. Students can independently press the buttons of the development boards in any combinations and in any sequence. Web camera that directed at the board allows students to observe its current image in real time. A workstation with operating system Microsoft Windows that can be accessed remotely with remote desktop protocol. All of the shown components makes up one instance of a learning management system. Workstation or laptops must have 3 free USB ports. One port used for USB ASP programmer. The second port is for Chipkit Uno 30 Chipkit microcontroller, remote hand of students, and third port is for web camera. As a result, unauthorized students located in any country in the world can connect to the workstation, develop, debug, and burn and compile C program to the ATmega 8 microcontroller, to the development board, run it for execution, press the buttons using the Chipkit microcontroller, and look through the camera at the 7 segment indicators. To start labwork, a student receives an IP address, a TCP port, and network credential. Login student 1 and open a remote RDP session from his home computer. One more student can also log on to the same computer, but with different login student 2. One more student with login student 3, and so on. Sure, student needs to understand that some operation they can do simultaneously, independently, and on the contrary, other operations they can do strictly sequentially, one after the other. Usually, the average student writes a program on C programming language using the integrated development environment Aware Studio is about from 30 to 60 minutes. Then a student spends approximately 5 minutes to burning the Atmega 8 microcontroller and checking the program operation. You can see that student spends 90% of time on development of the program without using devices connected to the computer USB bus. Obviously, many users can do this part of work and one computer at the same time. Accordingly, the students spend 10% of the time checking the program using USB devices, a camera, a programmer, and Chipkit microcontroller as a remote hand for pressing buttons. During use of these USB devices by one student, each of them must be blocked from use by another student. Therefore, in order to run any programs that use USB devices, student must launch the special loader programs manually developed by authors and put the appropriate button. This program has 4 buttons. The first 3 of them launch Extreme Burner to burn the compiler C programs to controller Atmega 8, party communication programs to press the button remotely at the development boards, and VLC media player to see video stream from web camera. When students click on the button, he successfully launches the programs, or such message will appear that this program has been already launched by another student. Student cannot predict the result. The fourth button send interactive message to all users logged on into operating system. So students have a reliable instant communication channel between themselves. In order to press the buttons on development board, students must use a party program that interacts with microcontroller Chipkit UNO32 via serial interface. When users successfully establish a connection with controller Chipkit, a short instruction on the screen appears. Enter 4 digits. 1 button not pressed, 2 button is pressed during a half of second, and 3 button is pressed permanently. Student must enter a command consist of 4 digits from 1 to 3. For example, 3, 1, 2, 1, 1, 2, 1, 1, and so on. Buttons are numbered from left to right. 1, 2, 4, 3, 4. Therefore, in order to press and release a button number 1 and not press other buttons, user need to execute the command 1 2 1 1 1. Number 2 must be just in position 1 on the command. Similarly, in order to press and release the button number 4, student need to execute the command 1114, 1112. The command 2222 secondly presses and releases all 4 buttons in sequence, but at any given time only one of the buttons is present, or none of buttons is present. Instead, to control a program running at the ATmega8 microcontroller, it may be necessary for different button to be pressed exactly at the same time. It's easy to do, but for user need to execute not one but 2 commands in sequence. Example 1. In order to simultaneously press button 1 and 4, 2 commands must be executed. 3112. Digit 3 on position 1 presses and holds the button 1, while button 4 is also pressed. Command 1111 is required to release all buttons after button presses at the same time. Second 2. In order to press all button 1, 2, 3, 4, the command must be executed 3332 and then 1111 to release all buttons. As a result, the student can operate with real laboratory hardware in the mode of synchronous remote laboratory work. In combination with network platform for collective interaction, the students will also be able to consult with teachers and other students, demonstrate his screen, and report on the completed laboratory work. Online platform for collective interaction only allows the lecturer to demonstrate the correct performance of laboratory work. However, the development of modern information technology makes it possible to build a specialized network channel, which allows authorized users to provide reliable access to the computers in the internal private networks of educational institutions and to all programs running on these computers. An almost unlimited number of students can work remotely at the same computer. Each must log in their login, unique within the computer. If one copy of the specific program is installed on the computer, several students can remotely log it on to this computer and run this program at the same time. If students use programs that use external devices connected to the operating system via USB, FireWire, serial interfaces, only one user should be able to run this program. To organize the queue of students, an additional loader must be used that starts the corresponding program only after checking that the same program process is not launched by another student. Laboratory computer on which student work remotely can have an additional controller to which the executing device is connected, for example a multiple contactor or relay. Such a device can help the student remotely push buttons and change the position of the switches on the laboratory equipment. Students can observe the hardware using a web camera opened in any streaming media player, such as Windows Media Player, VLC Media Player, and so on. Thank you very much.